Okay, so now let's have a discussion of question number 32. So this question says an optical instrument uses a lens of power 100 diopter for objective lens and 50 diopter for its eyepiece. When the tube length is kept at 25 centimeter, the final image is formed at infinity. So this question has two parts. The first part wants us to identify the optical instrument. So let's have a look on to the solution of A part first. सबसे पहले इस क्वेश्चन में हमें पावर गिवन है किस किस की. We are given the power of the objective lens which is 100 diopter as well as of eyepiece which is 50 diopter. तो अगर मैं पावर से फोकल लेंथ कैलकुलेट करती हूँ फर्स्ट लेंस की, that will come out to be 1 centimeter. And if I just calculate the power of the second lens, that will also come out to be 2 centimeter. Since the focal lengths that we have calculated are very small and the focal length of the objective is less than the focal length of the eyepiece and their difference is also very small, therefore it is a compound microscope. Okay, with focal length of the objective lens as 1 centimeter that we have calculated and the eyepiece has the focal length of 2 centimeter. So I hope how we have identified what is the type of the optical instrument which is given to us in the question is quite clear to you. तो यहाँ पर जब आप इस पार्ट को सॉल्व करेंगे आपको 1 मार्क मिलेगा इस पार्ट के लिए. इस पार्ट को सॉल्व करने के लिए हमें फोकल लेंथ निकालनी थी. सो व्हेन यू विल कैलकुलेट द फोकल लेंथ ऑफ बोथ द थिंग्स, that is both objective and the eyepiece, you will get half mark for each and hence you will get 1 mark when you will write that the instrument is the compound microscope. Okay, let's have a look on to the B part which wants us to calculate the magnification that will be produced by the instrument. See here, what is the formula of the magnifying power of the compound microscope? Because the image is formed at infinity and hence I can write this magnification to be the multiplication of the magnification which will be produced by the objective lens and the eyepiece. Okay, so that will be L upon F naught into D by Fe. So when you will be substituting the values, you will get the final result as 312.5. I hope that is clear to you. For this part of the question आपको 2 मार्क्स मिलेंगे. पहला मार्क आपको मिलेगा जब आप करेक्ट मैग्निफिकेशन का फॉर्मूला लिखेंगे, that what is going to be the magnifying power, and 1 mark you will get for the substitution of values as well as for the calculation of the final result. So this is how you will score 2 mark for this part and 1 mark for the previous part, which will give you 3 marks for this question number 32. I hope that is clear to you. Now let's move on to the discussion for the question number 33. This is the A part of this question. In this question we were asked 2 point charges Q1 and Q2 are kept at a distance of R12 in air. We need to deduce the expression for the electrostatic potential energy of this system. So this is the A part. Let's have a look on to the solution. तो इस question में we need to derive the expression of the electrostatic potential energy for the system of 2 charges. तो सबसे पहले we need to take up the system. So we have this system of 2 charges Q1 and Q2 as shown in the figure. They are separated by the distance R12. Now we need to find out the work done when we move Q1 from infinity to point A. Because when we have moved the charge Q1 from infinity to point A, there was no initial electric field and hence the work done was 0. On the other hand, the work done in moving the charge Q2 to this point B from infinity, we have to do the work which will be equal to the charge multiplied by the potential at that point. There is going to be the potential at point B due to this charge Q1. So this V1B is the potential at point B due to charge Q1. Okay, further, so this is the W2 which is Q2 multiplied by V1B. Now the potential energy of the system is equal to the total work done. So this total work done will get stored in the system in the form of its potential energy. So W1 is 0, W2 is this. So the potential energy of the system will come out to be 1 upon 4 pi epsilon naught Q1 Q2 by R12. So this is what was expected from us to write down as the solution of this part. This part was for 2 marks. So इस क्वेश्चन के आंसर को अगर आपने इस तरीके से लिखा है तो आपको 2 मार्क्स मिलेंगे. आपको 2 मार्क्स कैसे मिलेंगे? फर्स्ट ऑफ ऑल आपको लिखना पड़ेगा कि वाई W1 इज 0. आपको W1 कैलकुलेट करना है. यहाँ तक के लिए आपको हाफ मार्क मिलेगा. देन फॉर राइटिंग द एक्सप्रेशन फॉर W2 आपको हाफ मार्क मिलेगा. देन फॉर कैलकुलेटिंग दिस V1B एंड पुटिंग इट्स वैल्यू टू कैलकुलेट W2 आपको हाफ मार्क मिलेगा. And then calculating the final result, you will get half mark. So this is how you will get 2 mark for this part of the question. In the B part, they are saying if an external electric field is applied on the system, write the expression for the total energy of the system. Now, अब same system है as of part A, यानी कि 2 charges हैं Q1 Q2, लेकिन एक external electric field apply किया गया है. अब एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाई करने से क्या होगा? एट बोथ दी पोजीशंस, यानी कि Q1 के प्लेस पर और Q2 के प्लेस पर कुछ पोटेंशियल डिफरेंस आ जाएगा. VR1 इज द पोटेंशियल एट पॉइंट ए और VR2 जो होगा वो होगा पोटेंशियल एट द पोजीशन ऑफ चार्ज Q2. ओके, दैट इज एट द पोजीशन ऑफ पॉइंट B. सो पोटेंशियल एनर्जी जो होगी दैट विल बी इक्वल टू दी, और ड्यू टू द एक्सटर्नल फील्ड जो पोटेंशियल एनर्जी आएगी दैट विल बी इक्वल टू Q1 इंटू V, दैट इज द पोटेंशियल एट पॉइंट A. ओके, सो दैट विल बी Q इंटू V प्लस Q2 मल्टीप्लाइड बाय द पोटेंशियल एट पॉइंट B, और विच आई कैन से दैट एट द पोजिशन वेक्टर R2. सो द इंटरैक्शन potential energy of the 2 charges that we have already calculated in the previous part is this. So the total potential energy will be the sum of these 3, and hence this is how you will write down the expression of the total potential energy. अब ये part जो है वो 1 mark के लिए है. आपको half mark मिलेगा when you will write down till here that what is going to be the total potential energy due to the external field. Okay, and then when you will write down the total energy of the system in the presence of the external field, you will get another half mark. So this is how you will get 1 mark for this part of the question and total 3 marks for this question. I hope this question is clear to you. Now let's move on to the discussion for the question number 34. So this is the question number 34. इस क्वेश्चन में हमें पूछा गया है व्हेन अ कंडक्टिंग लूप ऑफ रेजिस्टेंस 10 ओम एंड एरिया 10 सेंटीमीटर स्क्वायर इज रिमूव्ड फ्रॉम एन एक्सटर्नल मैग्नेटिक फील्ड एक्टिंग नॉर्मली, द वेरिएशन ऑफ इंड्यूस्ड करंट इन द लूप विद टाइम इज शोन इन द फिगर. So this I is the induced current and this is the time, and this is the graph that will be formed between the induced current with time. Okay, so in the first part of the question we need to find out the total charge passed through the loop. So let's have a look on to the solution. So here we are given the resistance as 10 ohm. We are given the area of the loop as 10 centimeter square, which is 10 into 10 raised to the power minus 4 meter square. This is the graph. And to calculate the charge passing through the loop, what do we need to calculate is this area. That is area of IT graph. So when you will calculate the area under the curve, you will get the charge that is passing through the loop. So that is going to be the area of this triangle, which will give us Q as 0.2 coulomb. Okay, so in the first part we were supposed to calculate the charge passing through the loop, and for this complete calculation you will be getting 1 mark for part A. Now in the second part, what do we need to do is we need to find out the change in the magnetic flux through the loop. How you can find out the change in the magnetic flux? See, we know, let's have a look on to the solution. We know the EMF induced will be equal to minus N delta phi by delta T. Here N is the number of turns. So what is the number of turns? Number of turns is 1, so that will simply be 1. Now this EMF can be replaced by current into resistance. So that can be replaced by IR is equal to minus N delta phi by delta T. Now this I can be written as Q by delta T into r is equal to minus n delta phi by delta t. These two will get cancelled out. Okay. So we can simply get delta phi as minus qr by n. N is already 1. So if we talk about the magnitude of the change in flux, that will be equal to 2 Weber. Okay. So this is the second part. So if you have calculated the second parts, you will get the 1 mark for this part of the question. Moving on to the third part. In the third part, we need to find out the magnitude of the magnetic field which is applied. See, in the second part, we have already calculated the flux. So flux will be BA cos theta. So here in this case, what is this theta? Theta is the angle between the magnetic field and the area vector of the loop. Because in the question it is mentioned that it is perpendicular. See here, this is external magnetic field is acting normally. So it means it is perpendicular to the area vector of the loop, and hence the theta will be 0. So phi will be equal to BA. Okay. Now we have calculated phi in the previous part. We already know what is the area. So when you will substitute the value, you can calculate this B as 2 into 10 raised to the power 3 Weber per meter square. And for calculation of this part, you will get complete 1 mark. And this is how you can get 3 out of 3 marks for this question. I hope all these questions which were 3 marks questions are very clear to you. Now let's move on to the discussion for the next question. That is, we are going to talk about the discussion of the section D now, which includes 3 questions of 5 marks.